Hello. Good to see everybody here today. My name is Zach Friedman. I'm going to talk about unifying data governance with Immuta and AWS Lake Formation. Before I start, I'd love to get a sense of who's in the audience. So just by show of hands, who manages data lakes or works on teams that manage data lakes here? Cool. And then how about data and AI stuff? All right, awesome. Cool. So by the way, I have a special treat for you guys today. I have 12 whole slides where nothing I say is going to have anything to do with the company that I work at or the products that my team builds. So does that sound like a good deal? Hopefully. Here to talk about you guys today. How do access controls work in cloud data warehouses and data lakes? First of all, they work differently depending on the engine vendor that you're using to actually query the data. The security model is dependent on both what raw data is being secured as well as the engine which executes the queries on the resources that are being protected. Broadly speaking, there are 3 or 4 ways to protect access to data. Number one, you can control who's authorized to run a query at all on a resource. You can control which rows users are authorized to see when they run a query, if we're talking tabular data sources. And then you can control either how a user sees a column value or whether they can see or project that column at all, again, depending on the platform. And most interestingly, access controls work differently depending on your organization's own architecture. So we're going to walk through a survey of some different platform security models. First, we're going to talk about Snowflake. We'll compare that to Databricks Unity Catalog. We'll compare that to Amazon Redshift. And then finally, we'll compare that to AWS Lake Formation, which is the security model for Amazon Athena, Amazon EMR Spark, and Redshift Spectrum. Okay, so Snowflake supports table, row, and column level security. The way they support table level security is role-based access control, so you grant permissions on securables like tables to roles, and those roles have a role inheritance structure. Row level security, they have a concept called, or an abstraction called row access policies. It's basically a UDF where you use SQL to answer the question of should this user be able to see this a given row or not. And then they have column masking policies, which will change the way that a column is projected to a user when they query data differently depending on the user. Databricks Unity Catalog, typo on the slide. So they also have RBAC. They also have user-based access controls. They do not yet have role inheritance, though they may add that. Row level security and column level security works very similar, although in Databricks they're called row filters and column masks. So yeah, just slide typo. Amazon Redshift. So if table level security through access privileges for a user, to user groups, or to roles. For row level security, a few years ago they introduced RLS policies, which are awesome. It's very similar to how Snowflake and Unity Catalog work. And then for column level security, they have both CLS policies, but then they also have column level privileges or permissions for tables, which is obviously emanating from the Postgres heritage there. And finally, Lake Formation. So Lake Formation has 2 broad ways to do table level security. They have LF grants to IAM principals. They also have LF TBAC, which is sort of like ABAC, but you're basically doing grants based on if the data is tagged this, then grant it to this principal. Also not on this slide, but a super cool feature that AWS announced at the last reInvent, with trusted identity propagation and AWS IAM Identity Center. You can also do LF grants to those IDC users and groups. That's an awesome feature. Everyone should adopt that feature. It's super cool. For row level security though, they have data cell filters, which it can make a row appear or not for a user, but it's not a fully expressive UDF with you can't write arbitrary SQL in there. So what you can do it based off of is less than Snowflake and Databricks. For column and Redshift. For column level security, there's column level permissions for tables. So can you or can you not even see that this column exists? That can be based off of LFT back, and then there's data cell filters that also work for column level security. All right, so what if you rely on all of these security models? So you use Snowflake and Glue, or you use Unity Catalog and Glue. Everything is fine, right? No, there's a lot of heterogeneity that you deal with. So what about catalogs? And I don't mean a data catalog that is a business level catalog. I mean the Iceberg catalog or the Unity catalog type or Glue type of catalog. So open table format catalogs like Iceberg REST catalog and UC, which is kind of a catalog over Delta Lake. They're systems for managing metadata in distributed data lakes. They organize and track tables, schemas, partitions, and data versions, and the engines actually use them to do planning and to enforce authorization. So yeah, they provide centralized metadata. They provide, especially these, an express design goal of these open table format catalogs is to provide consistency across engines to enable interoperability with platforms like Spark, Flink, and Trino for unified access controls. And so instead of, writing some lake formation policies and writing some row access policies in Snowflake and writing some, column masks in Databricks and Unity, the goal is to enable interoperability so that the access controls work everywhere. And so they allow for table level permissions and some of the catalogs, for instance, Nessie, which is an extension to Iceberg REST catalog from Dremio, allows for version control, which it's pretty cool. And scalability, it's just it's part of the actual query plan. So the catalogs have to they can't be latent to respond with the metadata. So this is now a solved problem, right? Use a catalog, write all the access controls into the catalog, and it's everywhere. Not quite. So you can read the meme. It feels weird for me to read a meme. But basically catalogs don't have full parity yet with platforms. So now if we're looking at our ways to do access control, remember we have table, row, and column level security. So for table level security in the OTF catalogs, it is generally service account based RBAC. And so what I mean by that is, RBAC is role-based access control, so you're granting privileges to roles onto tables. But even beyond that, when you connect into, let's say that you, I'll pick on Snowflake. Let's say that you are using an Iceberg REST catalog implementation in Snowflake. Typically, what you're doing is you're passing a service account principal to be the one that the catalog is going to base authorization on. So it's not it's not the role that you're currently writing the query on, and it's not the user who's currently logged into the query editor on whatever engine or the studio. Row level security, there's none. But spec proposals do exist. We're excited about spec proposals that exist here. And then column level security, there are some column hiding hacks. Tabular did something kind of cool. They were the company that Databricks acquired, the founders of Iceberg. They did something kind of cool to create these virtual columns and move stuff around so that engines could kind of hide columns, but it wasn't a first-class thing. But spec proposals also exist for column masking and in Iceberg, and we're also very excited about those. So what do you do now? All right, so platforms that support open table formats, they'll typically extend their security model to support OTF tables the same as internal tables. So like, what do I mean by that specifically? Snowflake has RBAC with role inheritance, they have row access policies, and they have column masking policies. They have those for Snowflake internal tables. Snowflake also has iceberg tables, and so it's like, it's kind of like an external table on steroids, but you can create an iceberg table in Snowflake, and then you can also, like with the exact same, you can grant privileges to the exact same roles to the like iceberg tables as secure roles, exactly the same as you can do them to internal Snowflake tables. And so like the security model is still that of the engine. It's not like, there's no security happening at the iceberg catalog tier. But like this is true in Databricks for Unity, it's true with Glue and Lake Formation. You could have like a Glue table that's an iceberg table and a Glue table that's not an iceberg table, and that all like works the same with Lake Formation privileges. But because of this, you're still back to supporting each platform security model, right? Because like, unless you're only using OSS platforms like Spark and not Databricks, like literally Spark, Flink and Trino, not Starburst, and you, actually that might not be true, but and you only have coarse grain access control requirements, then catalogs don't help you like all the way with access controls yet. So, you can leverage a policy orchestration engine. So what is a policy orchestration engine? Does this work? Yeah, okay, nice. So if we build this up from the bottom, right? So there is like data stored in files and object storage, and then it is stored in a specific file format. Like we've definitely seen Parquet be the most popular, but like, you know, this is your lake in S3, and then you need something that lets these files, these engines treat these files like tables, not like files. That's what Apache Iceberg is. And then at some point here, you need a security model. Like, because, all right, you have the engines and you're querying a table, but like, where are we enforcing these access controls? And so the security models here, like I mentioned in the beginning, Lake Formation is the security model for Athena, Redshift Spectrum, and EMR Spark. Snowflake is the security model for Snowflake. Unity Catalog is the security model for Databricks. And then Trino has this awesome interface called System Access Control, which is the security model for Trino. And what our product, Immuta, does is it orchestrates, it's kind of like a security meta model, or it's a policy orchestration engine. You write a policy in our product, and you don't have to worry about the differences between these security models. Actually, just go to the next slide. You write the policy once here, we become the security model. We deal with like pushing the policies that you write in our security model into these underlying security models, and the like net end benefit is that the outcome is that if these tables live, if you're querying some, you know, like S3 tables in Athena, and you also have some Snowflake and some Trino, or some Snowflake and Databricks, and any combination of this, or any of the other platforms that we support that did fit on this slide, you're able to like unify access controls because we are pushing these policies in and orchestrating them based off of policy changes, also based off of like user attribute changes from the IDP, as well as like data attribute changes that could come from like a business catalog or business glossary. It could come from you like changing them in our product, or any number of other ways. So that is my talk. Thank you, everybody. I have time for questions if anybody has any.